Hey, this is a video for 7.3, thermal inversion. So go ahead and check out the overview and set up your guided notes. Now, in an urban environment, we have a lot of surfaces with low albedos, which means that they will absorb a lot of the solar insolation that is coming in, and that solar insolation will be absorbed as heat, and it will not be reflected back into the atmosphere. So because that is heating up around the surface, it will also serve to trap in a lot of obviously warm air, but also a lot of pollutants that are accumulating at the Earth's surface. Now, warmer air is less dense. So at night, when the air is cooler because of, there's no sunlight, the warmer polluted air rises off and dissipates into the atmosphere. Now, there is a situation called a temperature or a thermal inversion in which a layer of warmer air gets trapped in between two cooler layers of air. So you'll typically have cool air, warm air, and cooler air. And when you have a layer of warm air, you're still creating pollutants at the Earth's surface. But then when these pollutants rise up in the atmosphere at night, as typically will happen, they're caught in that area of the temperature inversion. Now, this is occurring oftentimes in mountain valleys where you have mountain ranges on both sides. This is happening in a few urban areas like Beijing. This happens in Los Angeles and Mexico City. Now, in areas that are mountainous, you're going to have areas of high pressure pressing down, and you're going to get a thermal inversion. So when the pollutants rise, they get trapped in this inversion. Now, there's a lack of air circulation. If you had a steady breeze, a steady wind current flowing, you will not get this. But this will happen typically in mountainous areas, not because of the elevation, but because of the geography or the geologic formations nearby. Now, this will also happen in coastal areas, and this is one of the things that happens in Los Angeles. So Los Angeles is on the ocean, on the Pacific Ocean, and there is a mountain range to the east of it. Now, you have layers or areas of high pressure. When you have a thermal inversion, remember that warm air is less dense. It wants to rise up, but this high pressure is keeping it from rising up. And you're accumulating these pollutants in the lower levels of the troposphere. Now, you have a predominant wind blowing off of the ocean, so you have an ocean breeze that is blowing these pollutants, they should, dissipate off and go higher up into the atmosphere. However, this mountain range is keeping it from dissipating. So this is what's happening in Los Angeles. Now, the key points to pay attention to are that the layer of warm air is trapping cool air beneath it. The pollutants are getting trapped, and it often occurs in valleys. So this was a lot of information, not a lot of time. Please respond to this check for understanding. And show me what you've learned by responding to this FRQ prompt. Explain how geographic features contribute to thermal inversions. I hope that this video is informative. I thank you for your attention, and I'll see you soon.